Hello guys and welcome to this YouTube video where we talk about multi-tenancy in NestJS. First of all, it's important to understand the difference between a single-tenant application and a multi-tenant application. So in single-tenant, one single instance of your application is used to serve only one customer. So having three different customers, you would need to have three different instances of your application running. Every single customer is going to have their own dedicated infrastructure. As you can imagine, this is very bad when it comes to cost and maintenance. So let's say you had 100 tenants, you would need 100 running instances of your application that you need to manage and maintain. That's not the best way to go with it. On the other hand, in multi-tenant applications, as you can see, we only have one single instance of an application, where this single instance is used to serve different tenants. And a tenant is an organization or companies. So here we have shared resources. This is good when it comes to saving cost and maintaining our resources. The multi-tenant application structure is mostly used in SaaS application, software as a service. Also, a side note, you don't always have to have a dedicated database for every tenant, as you can see here. So here we have one single instance of your app running, but we have different databases. So for example, this tenant 1, for example, has their own database 1, tenant 2 has database 2, and so on. This isn't always the case in multi-tenant applications. So here, for example, the graph to the right, it's a multi-tenant application. So just like we said, one single instance of your application is used to serve different tenants, but we have one single database. Now, in this case, of course, every record or every document in your database should have a tenant ID field specifying which tenant this record belongs to. That way you're going to be able to filter out the data before sending them to the correct tenant. But in this video, we're going to follow this approach, a multi-tenant application, one single instance of your app serving different tenants, but each tenant is going to have their own dedicated database. So here, the challenge is connecting to the right database to retrieve the right data for the right tenant. By the end of this video, you're going to be able to implement multi-tenancy in an NestJS application that uses Mongoose and MongoDB. Now, to make things a little bit more concrete, let's focus on these three databases, master tenant ABC and tenant XYZ. First of all, if we look at tenant ABC and tenant XYZ, we can see that there's a pattern in those database names. So at first, we have tenant underscore and then ABC XYZ. So the convention here is for every tenant dedicated database, I like to name the database as tenant underscore and then the tenant ID, which is a unique identifier for the tenant. Of course, here I kept it simple by calling them ABC and XYZ, but of course you would need to generate a unique identifier for the tenant. Every tenant database has a products collection. For example, tenant ABC has book 1, book 2, book 3, and then tenant XYZ has microwave, oven, and fridge as their products. So anytime someone from tenant ABC makes a request to fetch the products list, they should receive this list of the books, and then anyone from tenant XYZ making a request to our server should receive microwave, oven, and fridge. So the challenge here is analyzing whoever made the request, for example here ABC, to our route, for example get/products, so that we can switch the connection and connect to the correct database, in this case ABC, since the tenant making the request is ABC, so that we can retrieve and return the correct list of products. In that case, we would return book 1, book 2, and book 3. And now if we take a look at the master database, it's like a central component. It acts like a mediator. It's not where tenant-specific data is stored. Instead, it serves as a control center for your application. So for example, here we have the tenants collection, which shows the different tenants using your application, such as tenant ID ABC and tenant ID XYZ, which are the two different tenants that have each a different dedicated database. And we would typically have some metadata for each to identify them, such as the company name. We could have admin email for the company or phone number for the company and so on. We could also have a different collection for subscriptions, for example. We could have some authentication related data, global settings, configurations, some data that could be useful for the owner of this system to provide or to create analytics and dashboards and so on. And of course, we could also save the shared data or the common data in the master database. Now that everything is clear, let's get to coding. I have a boilerplate code here, so let's explain it quickly. In app.module.ts, I'm registering the config module and I'm loading the config file that we have here. We have the server port and the database connection string read from our env file, as you can see here. And then we are using the Mongoose module to connect to our database. We are using the for root async method that allows us to use an async factory function here, and we are injecting the config service to read the database connection string from our config module. We also have a tenants module and a products module that we're going to see in a minute. Now, if you're not very familiar with the config module and the Mongoose module, please go back and watch those 2 episodes in my NestJS series. Let's take a look at the general structure of our code. We have the config folder, which has the config file that we talked about. We have an empty middlewares folder. We're going to write some code here. We have the products and the tenants folders that have the different modules. We're going to see them in a minute. And we also have an empty providers folder that we're going to write some code in. And of course, we have our main.ts, in which we are bootstrapping our application and then listening on port 3000. Now let's take a look inside of our products folder, where we have file related to the products module. Here we have a product module class, we have a controller and a product service. Now they are empty, but we're going to write some code here. And then we have the product schema, in which we're using NestJS/Mongoose to create a schema for a product. We have name, description, and price. Those are the fields that we have seen here in a product document. If those are not familiar to you, you should go back and watch my Mongoose episode in my NestJS series. Now let's take a look at the tenants folder, in which we have the tenants module. As well, we have a tenant schema here. We are creating a schema with 2 fields, company name and tenant ID. Those are the fields that we have for every tenant document in our database, in our master database. And then we have our module class, of course, and we are using, or we are importing Mongoose module and then using the forFeature method to create our model definitions. So now that we have a schema here, we are creating a model for that schema so that we can inject that model inside of our service to use it to either fetch, update, delete, or retrieve some data. Now, if we take a look at our MongoDB compass, we can see that we have different databases. We have master, we have tenant ABC, tenant XYZ. We could also have 100 other tenants. So the number of tenant databases is dynamic. So how does NestJS knows where to register that model? Or whenever we are injecting a model and then saying find one, how does it know where it should search for that collection? Should it be in master, in tenant ABC, or where? Well, the answer is simple. If you take a look at our app module.ts, here, whenever we are connecting to our database using for root async, the connection string that is used is this one. If you take a look here, if you analyze it, we can see that we are connecting to our local database or to our local server, and then we are using the master database, which is this one. So now, anytime we use Mongoose module.forFeature and then we register a new model and then we inject it, is going to be applied on the master database. And if you've seen my previous video, you know that here we can also pass in a argument called connection name, and here, for example, we could say db1. So now, if we had another database here, if we were using 2 different databases, for example db1 and db2, anytime we come here and try to register a new model, we would need to specify the connection name. So here, for example, we can pass in a connection name, so we could say db1. So those models are being registered on connection of database 1. And here, of course, we would need to have 2 different connection strings for 2 different databases. That way, whenever we are injecting a model here, if you take a look, we can pass in a connection name argument. So here we could say db1. So now we are injecting this model, which is connected to database 1, which could be the connection string of master, for example. That way, in our code, we are able to choose which database a model belongs to. But of course, this isn't the way to do that, because the number of tenants that we have here is not static, it's dynamic. So we shouldn't be actually adding them here. We should only connect to one database, which is the master database. So we need a different way to actually know on which connection to register our models so that we know from where to fetch the data. Let's take it one step at a time, okay? Our master database, this is static. We know that we only have one master database. And by default, this is the database that we are connecting to in our app module. So the tenants which is a collection that only exists in the master database, it does not exist in tenant ABC nor tenant XYZ, should correctly be on the master connection string, which is correct here. By default, it's created and used on that connection. So for the tenants module, we don't really need to change or tweak anything in the code. But now what about the products collection that exists in every single tenant database? How do we know which connection to use and how to actually switch to that connection so that we can fetch and retrieve the correct products to the client? Let's go back to our graph that we've seen earlier. We need a way to figure out which tenant made a request so that we know which connection and which database to use. So what we could do is send some data in the headers of the request. So whenever we are making a request, we can send, for example, a field called tenant ID, which would have the tenant ID, for example, ABC. That way in our code, we can read that field from the request header, and we're going to be able to know which tenant made that request, and we're able to switch to that connection. So here, for example, in Postman, just like we have in our headers, user agent, accept language, for example, if you have multi-language, we have just added X tenant ID here, and the field value is ABC, which is this tenant right here. Now that we know we can provide a tenant ID in our request headers, there should be a way to actually check our request if it indeed contains that header parameter. If it doesn't contain it, we should throw an error. So we could use middlewares to do that checking for every request. So let's go ahead and create our own custom middleware. So I've created a tenants middleware here. If you're not very familiar with middlewares, I have a full dedicated episode on middlewares in my NestJS series. But basically, you just create a class. This class should implement the Nest middleware interface, which provides a use method that we need to implement, which has request, response objects, and then the next function as parameters. And of course, we should use @injectable to make this a provider. And now what this does is we're actually fetching the X tenant ID from the request headers, and then we're adding to string, because by default, if we take a look here, the request headers is going to return a string or an array of strings. So we're just making sure that it's one single string for the tenant ID. And then we're checking if it does not exist, meaning the user did not send a tenant ID, just like here. Then we should throw an error saying bad request, X tenant ID is not provided. We're logging it if it does exist. We are setting it on the request object for later access. So we could use it saying rec.tenantID. Of course, we're calling the next function. For this middleware to actually take effect, we need to register it. So what I did is I went to products module, and then here I implemented nest module. So I would need to implement the configure method. This configure method takes a consumer which is of type middleware consumer. All of this is already talked about in my episode. And then we could say consumer.apply. It takes an array of middlewares. We passed in our tenants middleware, which is this one. And then here we need to say for routes. We could either say star to apply it to all the routes, or we could just specify the controller. So now by saying products controller, every single route handler that exists here will have this middleware applied to it. So now if I go ahead and try to make a call to /products, which is this, it should return an empty array. If I hit send, as you can see, we actually got an error. And that's because we did not send a tenant ID. So the middleware is doing its job correctly. It is checking if we do have a tenant ID in the request headers. We don't have it, so we threw an error. Now let's see what happens if we add a tenant ID here. Now we have set the X tenant ID to ABC. If we hit send, and as you can see, we got the array. So we successfully went into the controller. And if we take a look at our logs, we can see ABC, which is our tenant ID. Now that we have the tenant ID attached to our request object, let's see how we can actually access it here to change our database. Now I'm going to show you two different ways. The first one is going to be dirty and not the best way to follow, but then I'm going to show you a second, more advanced way, which is clean and the way to go. So let's start with the first one. Here we can use @rec. This is the request object decorator, and it's from NestJS/common. And what we could do here is we could actually extract the tenant ID right away. That way we don't have to pass in the request object here and then say rec.tenantID. We could do it right away like that. And here we are sure that this value is not undefined, and that's because in our tenant middleware we are making sure that the tenant ID exists before continuing to the route handler. If it doesn't exist, we're throwing an error. And of course, we're making sure that this middleware is being applied to all the routes in our products controller already. So here we are sure we have the tenant ID. To make sure, we could say return tenant ID. And now if we save and hit send here, as you can see, we got the tenant ID, which is ABC in our response. Now in our product service, we created a method getProducts, which take the tenant ID, which we already got from the request here. And here we need to inject the connection, the native Mongoose connection. So we could say @inject connection. This is from NestJS/Mongoose. And then the connection object, which is from Mongoose. This is the native connection that we have in the Mongoose package. Now having this connection, we could use useDB as a method to actually switch to the correct tenant database. So let's go ahead and create a method that returns the correct connection based on the tenant. So I created a method getTenantConnection, which takes a tenant ID. And now here we need to return this .connection, the native connection, which by default, by the way, is pointing to this database master. So now we're taking that connection and we are going to say useDB, and then here we need to pass in the name. And if you take a look, switches to a different database using the same connection pool. So here let's go ahead, and in our database we are using a convention tenant underscore and then the tenant ID. So let's do that, tenant underscore and then our tenant ID. And here let's say tenant connection equal await this.getTenantConnection based on our tenant ID. And now that we have our correct tenant connection, so we are connected to the correct database, correct tenant database, we need to actually create a model on that connection, or actually retrieve an existing model from that connection. Just like we have a model here registered on the default connection, we need to create a model on this tenant connection based on the tenant ID. To do that, we can use the tenant connection and say .model. This either defines or retrieves a model, and if we take a look, it takes a name and then a schema. Just like here, whenever we are registering our models, the model definition takes a name and a schema, and of course some options or whatever. So it's the same concept here. The name would be our product.name. So we are using this schema now. The schema is product schema. Now that we have our correct product model pointing to the correct tenant connection, okay, we could say return product model.find, and then now it's going to return all of the products. Of course, here in our request we need to pass in the tenant ID XYZ. Let's see what happens. And as you can see, we got microwave, oven and fridge because the tenant ID is XYZ. So here, whenever we said get tenant connection, we switched to database tenant underscore XYZ, which is the second database, the second tenant database. The products are microwave, oven, fridge, the ones that we just received here. Now let's see what happens if we set it to ABC. If we hit on send, as you can see, we got book 1, book 2 and book 3, which are from tenant ABC. So this code is working correctly. Of course, in your application, you should also have guards, authentication, authorization guards, to make sure that a valid token is being used and that a tenant isn't pretending to be another tenant. So you should be writing code for that. I'm not going to cover it in this video, but in case this video gets a lot of views and you guys want to see it, I could make another video to show you that aspect as well. But for now, if you remember, I said that this is a dirty way. This isn't the best way. But if you're still watching, please leave a like, subscribe, and let's talk about a different way. Now, the reason why this isn't the best way is because there would be a lot of repetition in our code. So here we have getProducts. Let's say we had getProduct by ID and many other methods. Every single time we're going to have to fetch the correct connection and then create the model on that connection and so on. And this is all in only one module, which is the products module. What if we had other modules or other collections here, for example, items, receipts, roles, or whatever? We would need to be doing the same logic to get the correct model from the correct tenant connection and so on. Now you could argue that you could create a service, for example, tenant connection service, which returns the appropriate model, but still in that case you would need to fetch the correct model and call that method or that service in every single place you need to use the models. A better way would be to create your own custom provider with your unique tokens that you can inject here, that would return the appropriate model based on the tenant ID. And I'm going to show you what I mean in a second. In the provider episode, we talked about different ways of creating providers and using them. Just to remind you quickly, we said that the most basic provider that we could create is a service, for example, the product service, and this is considered a provider because it's marked with @injectable decorator. If you take a look here, decorator that marks a class as a provider. Providers can be injected into other classes via constructor parameter injection using Nest built-in dependency injection system. So here, to register this product service provider, we just had to add it to the providers array here as the class name. And by doing so, we were able to use it as a dependency inside of our products controller by simply injecting it inside of our constructor. So now this is a dependency and we can use it. We said that this is a shorthand way for a longer way, more detailed way of actually registering a provider, which would be using those properties: provide, use class, use factory. And this goes to show that a provider doesn't have to be a class. It could be a value, it could be an object, and so on. Now, in our scenario, we are actually forced to use the long way because we're not going to be using a class provider. Instead, we're going to use a factory. And just like they're doing here, we need to inject a provider here as a dependency so that we can use it here and switch to the correct tenant ID. Let's quickly look at this code. They are using the provide attribute, and then they are providing a string, which is the token name. And then they are using a factory, injecting options provider as a dependency, and then returning a database connection. What we're going to do is very similar, but we are going to return a tenant connection based on the tenant ID. So let's see how we can do that. So inside of our providers folder, I created a tenant connection provider by following the documentation here. So we have a provide attribute, and I set the name, the token, to tenant connection. And then we have a use factory that we're going to implement together right now. So to return the correct tenant connection, what do we need? We first need the tenant ID, which is added here, attached to the request inside of our tenants middleware. So of course, we first need to apply the tenants middleware to every single route that will use this tenant connection. We also need the Mongoose connection. So this one right here. Just like we did here, when we injected the connection, we used it to say use DB, and then we switched to the correct tenant DB. So that's what we need to do here logically. So we need to have two dependencies. The request object, which we can get from NestJS/core, which will have the tenant ID attached to it. So here we could now say request. And then the second dependency, which is getting the connection to the Mongoose database, which we could get from getConnectionToken, which is a method provided from NestJS/Mongoose. And now here we could use the connection as a dependency. Now we simply need to do the same thing that we did here. So inside of our provider, we need to return connection.useDB, and then here we're using the request.tenantID. Of course, for this to work, we need to respect the order of the dependencies here. Now, logically, we are going to have the tenant ID attached to the request every single time a request passes by tenants middleware. So we always need to apply the tenants middleware before actually injecting this provider. If we inject this provider using the token name anywhere that doesn't have the tenant middleware applied on, so we would be missing the tenant ID, it would be undefined. So let's handle that error. Let's say if not request.tenantID, we could say throw new internal server exception. So now anytime we inject this provider using the token name in any constructor, we're going to receive the connection of the tenant. Let's make sure that this is working correctly. So what we need to do is take this provider, let's go to the products module, let's register it here. So tenant connection provider. And now that we have registered this provider, we can inject it here using the token name tenant connection, which is the tenant connection of type connection from Mongoose. Now to check if this is working, let's go ahead and return the tenant connection.db.database name and open Postman and hit send. As you can see, we got tenant_ABC. So we correctly switched to the correct tenant connection. meaning the provider did its job. It provided the correct tenant connection based on the tenant ID field attached on the request. And all of this happened because we are applying the tenants middleware, of course. So now here, if we remove the tenant ID, if you hit send, of course, we got X tenant ID not provided, and this is an error thrown from the middleware. But let's say we forgot to actually apply the middleware at all. So here, let's remove this, hit save. If we try to hit on send, as you can see, we got internal error 500. Make sure to apply the tenants middleware, and this error is thrown from our provider right here. So now you can see we have successfully created our custom provider. Anytime we want to have access to the tenant connection, all we have to do is just inject this token, just like we did here, and you'll have access to the correct tenant connection. Of course, don't forget to actually apply the tenants middleware to actually attach the tenant ID to the request, and don't forget to send the tenant ID inside of the headers. This custom provider solved this issue. We no longer need to inject the connection, the Mongoose connection in our services, and then end up switching the database. But we still have one issue, which is repeating this part of the code, where we retrieve the correct model on that tenant connection. So let's go ahead and see how we can also create another custom provider, but this provider is going to fetch the correct model of the tenant connection. Now, there is one important thing that you should know, and to understand this, I added a log here inside of the constructor of the products controller, in which we are injecting the tenant connection, which is the custom provider that we just created. Okay, if you recall in the providers video, I said that here inside the injectable, we could specify two properties, durable and scope. Inside of scope, we have scope dot, and then we have default, which is a singleton, and then we have request, meaning anytime we make a request, a new instance of the product service is going to be created. Okay, so by default, it's going to be a singleton. So NestJS is only going to create one single instance of this product service provider, and then anytime you inject it or try to register it in a module, it's going to either create it if it does not exist or fetch the existing singleton. Now, when we created this provider here, which by the way, you should know that whenever you create a provider in general, so here if we take a look, we have the scope property as well. So that means inside of our tenant connection provider, we could also specify the scope of this provider. So here we could say scope, and then we could use scope.request, for example. And this makes sense because this provider should be recreated on every request. It shouldn't be a singleton. Here, in this case, it used to be a singleton because we were able to use the same instance, and inside of it, we were switching connections and fetching the correct tenant connection and so on. But here in this provider, it makes sense that this is a request scoped because we're first of all injecting the request object in it. And the request object changes. So the first request that I make now, if I hit send now, this is a context. If I hit send again, it's another request. So it is logical that this rebuilds every single time, because the first time I made a request, maybe it was ABC here. So it makes sense that it's going to return tenant underscore ABC. But if I make a new request with XYZ and then hit send, here the request object is going to have a different tenant ID, which is going to be XYZ. So obviously this is rebuilding. It's not a singleton like this one here. Now we don't really need to specify scope.request here to make it request scoped, because by default it is going to be request scoped because we injected the request dependency here. So to prove that this is a request scoped provider, I added console.log inside of the constructor of products controller. Now every time we make a request, so 1, 2, 3, those are 3 different requests. As you can see, the controller got built 3 times, so inside, inside, and inside. And that's because this controller depends on tenant connection, and tenant connection is a request scoped provider. Now of course it's better to have singletons, but if you read the documentation, we actually do need to use request scoped whenever we have a multi-tenant application. So this is like an exception. Of course, there's going to be a bit more latency, so the time to get a response will take a bit longer, since every time we're rebuilding this controller, for example, because it depends again on a provider that is request scoped, but it's not going to be a huge difference. And in this case, we have no other choice since this depends on the request, because every request could be from different tenants. And to prove that the reason this products controller is being rebuilt every single time is caused by the tenant connection provider being request scoped, let's remove this. Okay, let's remove this and return 1, for example. Now, if I make different requests, let's see if we actually go inside this controller multiple times. If I hit send, 1, 2, 3, if you take a look, we didn't get inside anymore. We didn't get this log that we have inside of our controller. We actually got it only once. If we go back up here, Mongoose module dependency initialized, like it only happened here whenever we were initializing the products module. So now it's back to being a singleton. This was just a side note so that you understand what's happening here. Now let's jump back and create the second provider, which is going to return the correct model for the correct tenant. Okay, I have created another file, tenant-models.provider.ts, and I copy pasted the same code here. So this code, I added it here, but this time I have nested objects. So I have a tenants model object, and then inside of it, I have a product model. This is going to be where we actually have our different models that are based on the tenant connection. So here, let's call this product_model, for example. And then let's remove this code here, and this code here, and this here. What do you think we need as a dependency here if we want to return the correct model? Well, to help you out, if you take a look here, the products model depended on the tenant connection. So we used the tenant connection, then we did model, and then we passed in the actual name and the schema. So we can do the same here. Here, we could say return tenant connection.model and then pass in the object. So product.name and then product schema. And of course, to have access to the tenant connection, which is tenant connection, which is of type connection, to be able to use that, we need to inject it as a dependency here. And to inject the appropriate tenant connection, we can use our own custom provider. So now here we could say tenant connection, this is the token. We are injecting our own custom provider here. And now that we have access to the tenant connection, we could use that model to retrieve the model appropriate to the correct tenant connection. Let's see how we can use that in our code now. So in the products module, just like we have tenant connection provider, we're going to use tenant models.product model. So we are going to use this provider right here, which is going to return the correct model for the product on the correct tenant connection. And now we are able to inject it using the token here, which is product model. So inside of our product service, we no longer need to have async get tenant connection. We no longer need to create the connection here and then the model. All we have to do is simply use @inject, which is from NestJS common. And then here we can specify the token name, which is product model. And of course, this works again because we registered the product model, the custom provider that we created here, which is this, which has this token here. So we could say private, and then this is of type model. Let's call it product model. And this is of type model from Mongoose. And then here it's of type product. And now what we could do here is just say return this.productModel.find. We no longer need to pass in the tenant ID here. And then in the controller, we no longer need to get the request and extract this. So we need to remove the tenant connection here. We no longer need it. And now here, all we have to do is just say product service.get products. No longer need to pass anything. So if you take a look here, all we're doing is we are injecting the product model in our constructor and returning it. Let's see if it works. Send. And as you can see, we got book 1, book 2, and book 3, which are the books from ABC, tenant ABC books. And then if we use XYZ, if we hit send, as you can see, microwave, oven, and fridge, which are the products inside of tenant XYZ. So now we can see that this is working beautifully. I just want to add one more thing. If we go ahead and add in some random name here and hit send, Of course, it returned an empty array because this tenant does not exist. But if you go back to our database and refresh, as you can see, it have created this tenant. So here, a hacker could come and then start spamming random names and creating useless databases here. To stop this from happening, we need to add some logic in our middleware, in our tenants middleware, to ensure that the tenant ID provided in the request headers is actually a valid tenant. So let's go ahead and inject the tenant service inside of our tenants middleware. That way we can use getTenantById and check if a tenant actually exists. Of course, we're going to get an error here that it cannot resolve some dependencies. To fix that, we could make the tenants module as global. And we need to export the tenant service so that it can be used by other modules. So by making this module as global, we no longer need to import the tenants module everywhere or every time we need to use the tenant service. We only need to import it once inside of our app module, just like we're already doing. And now, since this is global, the exports array that contains tenant service is used as a dependency anywhere in our app, including the middleware. So now if we save, if you take a look, as you can see, NestJS is no longer complaining and you can use the tenants service. There's a workaround so that we no longer need to inject or register the tenant connection provider, which is our custom provider that returns the tenant connection. We currently have to register it everywhere we need, or in every module we need to use it as a dependency. If we remove it now, it's going to throw an error, of course, because it's not registered. However, since tenant module is a global module, registering the tenant connection provider here, and then exporting it with the rest of the providers. If we save, as you can see, this is the workaround I was talking about. So having a global module and registering some providers and then exporting them, if this global module is imported in the app module, everything in its exports array, every provider here, will be available in the whole application. So now simply we just need to get the tenant by ID using the tenant service, passing the tenant ID from the request headers, and if it does not exist, we throw an error. So now if you take a look in Postman, if we hit send, tenant does not exist. If you try to add others, send, tenant does not exist, send, tenant does not exist. Of course, we still have this one because I did not delete it. But if we delete this one and we refresh, we have not created any undefined tenant or any random tenant that does not exist in our system, because now in our tenants middleware we are ensuring that the tenant ID is valid. And of course, this checking is happening inside of our master database, inside of our tenants here. And of course, now this product service is request scoped since it is depending on product model. And just a side note, the way NestJS handles dependencies is, for example, it looks at this service, it sees a dependency, a provider, which is product model. It goes to product model, which exists here, and then it checks tenant connection. So now it knows product model depends on tenant connection, which means that NestJS should create the tenant connection provider first. So it will go to tenant connection, it will take a look here, it will take a look at request and get connection token. Since tenant connection depends on those should be created first. That way, NestJS is going to create the dependencies tree to know which dependency should be created before the other so that they can be injected as dependencies in each other. So to summarize everything we said, in a single tenant application, we have different instances of their app running, and every instance only serves one client. So we have different infrastructures, which is very costly and hard to maintain. On the other hand, multi-tenant applications have only one single instance of the app running, which is a shared resource, which is used by different consumers, different tenants at the same time. We could have one dedicated database per tenant, or we could have one single database. In our example or in our implementation, we use different databases. So here, if you take a look, we have tenant ABC, tenant XYZ, and then the master. In case a user makes a request and from a certain tenant and we need to retrieve the correct information, first step is to actually send a tenant ID in the headers of the request, and then we need to have a middleware that is going to receive that request and ensure that the request headers exists, which is tenant ID. If it does not, it throws an error, and then we need to verify the validity of that tenant before continuing. If the tenant is valid as well, we need to attach the tenant ID on that request. We saw two different ways of actually changing the connection based on the tenant ID and then retrieving the correct model on the correct connection. The cleaner way was to create two different providers, one for the tenant connection, so we used provide, and then this is a custom provider. Our own token is tenant connection. We are using a factory which depends on the request object get connection token, which retrieves the connection of our application, which is the default connection which exists in app module, which is the connection string passed here, which is connected to master by default. And then here we are making sure that we have a tenant ID on our request. If this is the case, we are using connection.usedb, and then we are using the correct tenant database. Now we are creating another provider, or here we can have a list of custom providers. Every model will have their own provider with their own token. So we created product model token that whenever injected will retrieve the correct model. Of course, it depends on the tenant connection provider that we just created here, so it's used as a dependency. And here we are using tenant connection.model to retrieve the correct model for the correct schema. After all of this is done, we can now register the product model and use it in our application. For example, in our product service, after of course registering the provider here inside the module in the providers array, we are able to inject it using the token name in our constructor for the product service, and now we can correctly call the correct collection in the correct database. Of course, this service is request scoped since it depends on the tenant model provider, and the tenant model provider depends on the tenant connection, and the tenant connection depends on the request, which is different in every request, of course. If this video was helpful, please leave a like, subscribe, give me your feedback, and I'll see you next time.